and welcome to History of the Atom. My name is Norman St. Bergenstein, and today we are literally going to go back in time to interview the people who discovered the atom, going as far back as 400 BC to yesterday. We are first going to interview Democritus the Philosopher, who is with my colleague, Shirley now.
Yes, hello. I'm very pleased to meet you and be on this interesting show.
You were the first person to come up with anything close to the atom. What did you discover?
One day I was eating my glorious grapes when I decided to split it in half. Then again, until I could split it up no longer. But deep down inside my wonderful, glorious, extremely smart mind, I knew that it could still be divided. So I thought, what would happen if there was a piece of matter that could no longer be broken down? I thought this piece of matter would be indivisible, so I named it atomos, which in Greek means indivisible.
Back to you, Norman.
Yes, how amazing. Now let's go to Harry Otter, who's with John Dalton, a British chemist, almost 2,000 years later.
Now, Mr. Dalton, can you please tell me what you discovered about the atom?
The atom? You know, I was a meteorologist, then a chemist, right?
Yes, but can you please tell us about the atom?
Very well then. I propose the first atomic theory, which states that all matter is composed of atoms, and that atoms can form to create compounds.
Thank you, Mr. Dalton. Norman?
Yes, Harry, isn't that fascinating? Next, we are going to visit one of the most inspiring scientists of the 1800s. Shirley?
Standing next to me is J.J. Thompson, a British physicist. May I call you J.J.?
No.
Alrighty then. What makes you so special in the history of the atom?
Well, I discovered the electron.
Wowzers.
I theorized that the atom, which was a dense sphere, had electrons scattered throughout on rings. These electrons had a negative charge, so this dense sphere must be positively charged in order to balance it out.
J.J.,
I told you not to call me that.
you called it?
I called it the plum pudding model.
Because?
I just love plum pudding so much, you know? I mean, it's just so delicious. Got
right.
these little plums in it, just like
back to you,
electrons in it. It's just
Norman.
delicious. I could eat it every day for my entire
Yes. Thanks, Shirley. Now we're going to go to Canada, 1921, to talk to Harry and Ernest Rutherford. Harry?
Thanks, Norman.
Did you know I won the Nobel Prize for Radioactivity in 1908?
Oh.
In Canada!
Oh, okay. I love Canada.
So do I! And now I'm a really important guy.
Does the reason have anything to do
With the proton? It has everything to do with the proton.
Oh.
Which I released radioactive alpha particles and shot them at a thin sheet of gold foil. I thought that the particles would go straight through, but instead some of them bounced off and went every direction. I knew that alpha particles are positive. I also knew that positive particles deflect other positive particles. By this information, I inferred that in atoms there must be a positive center surrounded by mostly empty space. Would you like to see my diagram? It's beautiful.
You know, we're almost out of time.
You know what? You have to see this diagram.
Back
Look
to
at
you,
this.
Norman.
Look at this.
Moving on. Let's go to Shirley in Denmark, who's with Niels Bohr.
Mr. Bohr, can you please tell us what you discovered about the atom?
Nice hat.
Thank you. I cut it. It's new.
Well, what do you want to know?
Well, I heard you discovered something about, like, energy rings.
Levels.
Levels! Right. Didn't you do something with hydrogen?
Yep.
Can you please explain that then?
Nope.
Okay then. Can you please tell us about your energy levels?
Fine. I found how electrons are a certain distance from the nucleus on energy levels. Then I found that the electrons move from energy level to energy level when they lose energy and gain energy. The further away the rings are, the more energy they have. The electrons on the furthest rings are called valence electrons.
Okay, thank you, Mr. Bohr. Now, Norman, isn't that just fascinating?
It was actually pretty boring, but after talking to some
atom scientists of the past, let's talk to some modern-day atom researchers. Sitting here next to me is Catherine Johann.
It's pronounced Johann.
Oh, my bad.
Oh, sorry, I'm late, guys.
And this is Stella Skullblacken what?
It's Skullblackenstein.
It's just as simple as a quadratic equation.
oh man.
Yeah, go on.
Yeah. Could you please describe to me and my viewers the modern-day model of the atom?
Well, it's very similar to the Bohr model, except we've made a lot of improvements with the energy levels.
Yes, in the Bohr model, the energy levels are very neat and organized, when really we know now that they're much more chaotic than that.
We call it the cloud.
Yes.
The electrons are moving at the close to the speed of light and are always changing their energy levels.
Yeah, so instead of moving like this, they're more like this.
How cool. Thank you very much, ladies. And thanks to all of our special guests of the past.
No.
Thank you.
Have you ever wondered what a pareidolia means? Well, tune in next time to find out.